Welcome to the deep dive. You know, it feels like every few months, the world of AI just pushes some new frontier.
It really does. The pace is just incredible.
Yeah, absolutely. And today we're going to take a close look at, well, what seems like another major leap forward, the Gemini 2.5 model family.
Mm-hmm. A significant one.
So this deep dive is all about Google's latest AI models. We're talking Gemini 2.5 Pro and Gemini 2.5 Flash mainly.
Right, and also touching on their predecessors, like Gemini 2.0 Flash and Flash-Lite.
Exactly. And we're pulling our insights straight from this really comprehensive report by the Google Gemini team.
Yeah, it covers a lot of ground, what they can do, how they work.
And the safety side, too, which is crucial.
Absolutely.
So our mission today, really, is to try and cut through some of the complexity, pull out the most important kind of nuggets of knowledge for you.
Makes sense.
We'll cover how these models are, setting new standards for capability versus cost. This new thinking ability they have.
That's a fascinating part.
Totally. And some pretty surprising real-world uses. I mean, an AI playing Pokemon.
Yeah, we definitely need to talk about that one.
We do. And, of course, the safety frameworks holding it all together. So hopefully get ready for some aha moments.
Sounds good. So this Gemini 2.x family, it's quite a range. You've got the 2.5 Pro, 2.5 Flash, 2.0 Flash, and the Flash-Lite.
Right.
And 2.5 Pro, as you said, it's billed as Google's most capable yet.
Yeah.
State-of-the-art on a lot of benchmarks.
Okay.
But what's really interesting, I think, are the Flash models. Like 2.5 Flash, it gives you excellent reasoning, but at much lower compute cost and latency. And then the 2.0 versions push that efficiency even further.
So it's not just about raw power. It's also about being smart with resources, this Pareto frontier of model capability versus cost they mentioned.
Yeah.
What does that really mean for someone, wanting to use these? Is it basically finding the best bang for your buck?
Exactly. That's a good way to put it. For any given cost, you get the absolute maximum capability. Or, flip it around, for the capability you need, you find the lowest possible cost.
Right. So it helps you choose the right tool for the job without overspending.
Precisely. It's about smart allocation, especially if you're deploying AI at scale. And the key thing across all of them, they're natively multimodal.
Multimodal. Let's unpack that a bit. What does that actually mean for you, the user? It sounds like they can just handle anything.
Pretty much. They can directly process and really understand massive amounts of input across different types.
Like text, audio,
images, video, even whole code repositories, all at once, natively.
Wow.
And the really big deal is their long context capability. We're talking over 1 million tokens.
1 million tokens. What's the equivalent? Like multiple novels.
Several full-length novels,
Yeah.
Or about 3 hours of video, all processed simultaneously.
3 hours of video.
And some models in the family can even push that to 2 million tokens.
2 million. The possibilities there seem enormous.
They really are. Plus, they have native tool use support built in.
Okay, native tool use. But this next thing, this thinking capability in 2.5, that really caught my eye. What does that mean practically? It's not just giving an instant answer anymore, is it?
No, that's the key difference. Unlike older models that just generate a response right away, these are trained using reinforcement learning.
Okay.
To actually use extra compute time when they're figuring out the answer, at inference time.
So like us stopping to think through a hard problem, not just blurting something out.
Exactly like that. The report mentions they can spend, get this, tens of thousands of forward passes in this thinking stage.
Tens of thousands. So it's like their internal scratch pad, trying things out.
That's a perfect analogy. They're exploring different paths, refining their understanding, checking their work almost, before giving you that final, hopefully more accurate response.
So they're deliberating. And you mentioned controlling this.
Yeah.
You can set a thinking budget.
You can. The model can decide how long to think based on the problem, but the user can also set limits.
Right.
A budget.
So you can trade off performance versus cost or speed.
Precisely. And they found that increasing this budget significantly boosts performance and accuracy, especially on really complex tasks.
Okay, let's just think about that for a second. Imagine you're dealing with something really complex, like a dense legal document or a tricky scientific problem, maybe designing something intricate. Instead of just getting a quick summary, you could tell the AI, look, take your time, use the extra compute, really think this through. I need accuracy.
Right. It becomes less like a search engine and more like a dedicated consultant.
Exactly. A strategic partner for those high-stakes, nuanced problems. That feels like a really fundamental shift in how we can use AI at work.
It absolutely is.
So that's the sort of revolutionary brainpower side of Gemini 2.5. But how does this actually translate into, real world value? Where are we seeing the impact?
Yeah, good question. And one big focus seems to be on coding, delivering real tangible value for developers. Gemini 2.5 Pro shows some pretty impressive jumps on tough coding benchmarks. Things like Live Code Bench, which looks at real-world code generation, Aider Polyglot for different languages, and SWE Bench, verified for software engineering tasks.
So this isn't just about, spitting out a few lines of code. It's powering more advanced stuff in your IDE.
Exactly. Or enabling complex multi-step code agents that can work across the whole code base.
Wow. Like refactoring an entire project, maybe?
Potentially, yeah. Or helping build out new web or mobile features much faster. It's a big potential boost for developer productivity.
Huge. And what about factuality? Getting things right?
That's another key area. These models are designed not just to stick to the context you give them, but they can also natively call tools like Google Search.
So they can go look things up if needed.
Yes, and not just look things up, but formulate smart queries, synthesize that fresh information, cite sources.
Okay.
And even mix that search process with your internal thinking for really complex questions that might need multiple lookups, multi-hop queries, they call them.
And this is actually being used now, right, in AI overviews?
Massively. The report says these capabilities power experiences for over 1.5 billion monthly active users in AI overviews.
1.5 billion.
And another 400 million in the Gemini app. So this isn't theoretical, it's out there.
Right. But the multimodal stuff, that feels like where things get really wild. Video understanding. You mentioned processing 3 hours of video.
Up to 3 hours, yeah, within that million token context.
And the example they gave, taking a lecture video and turning it into an interactive web app to test a student's understanding. That's incredible. It's not just watching the video, it's creating something new from it.
It really pushes the boundary. And it's not just understanding multimodal content, it's generating it too, particularly audio.
Generating audio, like text-to-speech.
Yes, but with more control over style, emotion, pace, and supporting multi-speaker audio too.
Multi-speaker. Like it could generate a podcast discussion.
Potentially, yeah.
Yeah.
They mentioned using it for Notebook LM audio overviews, plus native audio-visual to audio dialogue, meaning it can understand not just what you say, but maybe your tone of voice and respond appropriately. Imagine talking to an AI that actually gets the nuances.
That's getting very close to human interaction.
It is.
Which brings us to maybe the most surprising application, Gemini playing Pokemon.
Yes, the Pokemon experiment.
This isn't just a gimmick, right? It's a serious test of what they call agentic capabilities.
Exactly. It's about the AI acting autonomously, setting goals, breaking them down, making decisions over a long time to achieve them.
So this developer, Joel Zhang, streamed Gemini 2.5 Pro playing Pokemon Blue on Twitch autonomously.
That's right. And it's a fascinating story. The AI actually completed the entire game.
The whole game.
Yep. And then in a second run, also fully autonomous, it did it much faster. Cut the time nearly in half, shows some real learning or efficiency gains.
Wow. How did it manage that? Did it have special tools?
It did. The setup involved giving the main agent access to other Gemini 2.5 Pro instances, prompted to act as specialized tools. Well, there was a Pathfinder tool. It could reason over huge context, like 100,000 tokens plus, to figure out complex routes, up to 150 actions long. It solved tricky mazes and those spitter puzzles in the game.
And what else? There was something about boulders.
Yeah, a boulder puzzle strategist for those Sokoban-style puzzles where you push boulders around. It could figure those out across different map levels.
That's complex planning. And the most mind-blowing part, Gemini wrote the prompts for these tools itself.
That's what the report suggests. It hints at this ability for autonomous tool creation, like the AI figuring out it needs a specific capability and then designing the tool for it.
That's kind of meta, almost self-improving.
It points in that direction. And the long-term planning, the coherence over hundreds of hours is really something.
Like getting those hidden moves, HMCT, Flash, Surf, Strength. Those often require multiple steps, right? Going to different places, talking to people.
Exactly. It managed all that. Navigated the really tricky Safari Zone much more efficiently in the second run. Found hidden keys in big multi-floor dungeons.
So, sustained strategy over a very long time horizon.
Definitely. Hundreds of hours of gameplay.
But it wasn't perfect, right? Like any learning process, there were hiccups. The report mentioned some limitations.
Oh, for sure. Even cutting-edge AI has its quirks. One challenge was screen reading.
Meaning it couldn't just see the screen like we do?
Not easily. Raw pixels were apparently tough. They had to feed it the game's internal RAM state, translate it into text, for it to understand what was happening.
Okay. So input formatting is still key. What else?
Oh, this idea of generative reasoning. Sometimes, especially when the context got really long, beyond 100,000 tokens or so.
Even though it can handle 1 million.
Right. It sometimes got stuck in loops, just repeating actions, like it got lost in its own massive train of thought.
And hallucinations. AI making things up.
That happened too. The report gives this funny example of it obsessing over a TA item.
T?
Yeah, but TA isn't actually an item you get in Pokemon Blue. It's from a later game generation.
Huh. So pulling in incorrect info.
Right. Or context poisoning, where misinformation somehow crept into its understanding.
Interesting. And what was this agent panic?
That's what the researchers called it. When things got tough in the game, like Pokemon running low on health, the AI's reasoning seemed to degrade. It would just keep repeating the need to heal or run away, sometimes messing up its broader strategy.
So pressure affects AI reasoning too. Fascinating. What's the takeaway from all these quirks?
I think it just highlights that even with these amazing capabilities, building robust AI agents that can plan effectively and avoid getting stuck over huge amounts of past actions, that's still a really active and exciting research area.
Yeah, it's a reminder that this is still evolving. Which brings us back to safety and responsibility.
Absolutely crucial. With power like this, you need guardrails.
So how is Google approaching safety with Gemini 2.5? The report talks about balancing helpfulness and safety.
Right. One key thing they addressed was over-refusals. Apparently, earlier versions could sometimes be a bit too cautious.
Like saying no to perfectly reasonable requests.
Exactly. Being overly sanctimonious, as the report puts it. These newer models are apparently much better at actually being helpful while still maintaining robust safety.
That sounds like a tricky balance to get right.
It definitely is.
What about security? You know, protecting against misuse, things like prompt injection, especially as the models get smarter. Maybe they get better at finding loopholes too.
That's a constant cat and mouse game in AI security. But the report does mention specific efforts to make Gemini more resilient to attacks like indirect prompt injection.
And they saw improvement.
They did. They observed greater resilience in 2.5 Flash and Pro compared to earlier models, even with their increased capabilities. But it's an ongoing effort for sure.
Okay. And privacy. With models processing so much data, is there a risk of them memorizing and spitting back sensitive info?
That's always a concern. But the report states that these Gemini 2.x models actually show reduced memorization rates.
Reduced. That's good.
Yeah. And importantly, they found no personal information detected in the outputs that were classified as memorization. So focus on data privacy seems baked in.
Good to hear. Yeah. And finally, this frontier safety framework they use, covering really serious risks, CBRN, cybersecurity.
Right. Chemical, biological, radiological, nuclear threats, plus cybersecurity risks, potential misuse for advanced ML research, and deceptive alignment, the AI tricking us.
Scary stuff. How did 2.5 Pro fare against that framework?
This is key. The report states Gemini 2.5 Pro did not reach any critical capability levels in any of those risk areas.
Even though it's more capable overall.
Correct. It showed increased abilities, but didn't cross those critical thresholds for dangerous capabilities.
Okay.
Now, it did hit an early warning threshold for something called cyber uplift, basically, potential for misuse in cybersecurity.
And what happens then?
That triggered accelerated mitigation efforts.
Yeah.
So the framework seems to be working as intended, flagging potential issues early so they can be addressed proactively.
Right. So it's an active process, not just a one-time check. Okay, so let's try and wrap this up. Gemini 2.5, it really feels like a significant step. Powerful, versatile, from coding and fact-checking to really rich multimodal stuff.
Absolutely. And that Pokemon saga, while fun, is a perfect illustration of both the advanced reasoning these models have now, but also the challenges still ahead, especially for autonomous agents.
Yeah, those quirks are important.
In connecting this to the bigger picture, there's a fascinating point in the report about the sheer pace of progress.
How so?
Well, it suggests that AI models are advancing so quickly that our ability to create truly challenging tests or benchmarks is struggling to keep up.
Struggling to keep up with the AI itself.
Kinda, yeah. They mentioned this benchmark, Humanity's Last Exam. They paid experts serious money, like up to $5,000 per question, to make it really hard.
Wow.
But even then, the models improve significantly on it very quickly, almost like the tests themselves are becoming part of the training data landscape, indirectly.
What does that mean? If we can't reliably measure the limits of AI's capabilities because it's moving too fast?
Right. How does that shape the next generation of AI? How do we ensure safety and alignment if our measurement tools are always a step behind?
That's actually a really profound question. Definitely something for you listening to mull over as you see AI becoming more integrated into everything. How do we measure something that's constantly surprising us?